In the 2014 version of the National Electric Code, Article 240.87, they introduced some requirements associated with arc flash and mitigation of those systems. So anytime we're looking at a breaker that's 1200 amps or greater, we're now required to do something to mitigate the incident energy associated with people that could be working on or near that energized electrical system. And the methods of arc flash mitigation include zone interlocking, differential relaying, a maintenance switch with indicators, arc flash mitigation, instantaneous trip, instantaneous override, or any other type of approved method to reduce the amount of incident energy. And so let's take a little closer examination of some of these methods of arc flash reduction. So one common approved method for arc flash reduction is actually the use of fuses. Fuses have been used for many, many years to reduce incident energy, mainly because they're quick or very fast trip time. When you design a brand new power system and you design it with fuses throughout, you can set up some very good coordination. However, you can't just come into an existing electrical system and incorporate fuses upstream to reduce the amount of incident energy, because now you have coordination issues between fuses, circuit breakers, and other relaying that you might have currently inside your equipment. Other types of methods that are approved are circuit breakers with maintenance mode or zone interlocking systems. Switchboards that contain molded case circuit breakers, you can get zone interlocking, which actually allows for coordination and fast tripping times for arcing events as well as short circuit current events. The maintenance mode circuit breaker has been around for a number of years now. The maintenance mode circuit breaker can be a good option for reducing incident energy, but you got to remember whenever you're using a maintenance mode circuit breaker that the arc flash mitigation is not something that's done automatic. And the reason is that the maintenance mode circuit breakers requires personnel that are going to be working on or near the energized circuit to actually energize or de-energize the maintenance mode circuitry. And how that's done is when nobody is working on the system, the maintenance mode breaker is off, all your selective coordination is in effect, and whatever incident energy levels are calculated based on the standard overcurrent tripping times of the circuit breakers is in place. But whenever maintenance will have to go on inside the switchboard, the electricians or technicians would come over, they would energize the maintenance mode switch, and what that does is basically turns everything over to instantaneous. So if there's any type of fault current that's known or detected, then that could produce an arc flash event, then that would go to instantaneous and trip very, very quickly. It does reduce the incident energy significantly. However, the downside is that when it is in maintenance mode, then you have no coordination between your different circuit breakers. And a fault downstream may take out your whole facility because it goes automatically up to the top breaker. Circuit breakers also come with arc flash relays built into them. There are a few manufacturers, Schweitzer, ABB, General Electric, that have arc flash relays that go into the switchgear power breakers, whether they're low voltage or medium voltage. These are good devices that you can use. Most of them are current-driven devices, so that when they detect a arc flash through overcurrent and more along the lines of the short or arcing current, then it will trip the breakers and remove power from the system. Another method that has been commonly used is arc-resistant gear. Arc-resistant gear includes some types of overcurrent protective devices, whether it's zone interlocking or established arc flash relays within the switch gear itself. A new technology that's been out for approximately 5 years now is a external arc flash relay. And I have a picture we have a unit over here. This is the TRC P1 arc flash relay system. This device is intended to go on existing power systems. And we connect up to it through external power, which powers the device. And then we feed our trip mechanism into the shunt trip of a molded case circuit breaker. And then that way we can detect an arc flash and then trip the circuit breaker that feeds the electrical gear, thereby reducing the incident energy and making it a little bit better workplace for our people that have to work around energized circuits. So let's talk.